Assalamualaikum.
Oh,
Assalamualaikum. How are you, Shari?
I'm good.
Great. Is my voice is clear?
Yeah,
Are you ready for today's lecture number 8?
yeah,
Have you revised what we did yesterday
yeah, a little bit.
regarding Newton laws of motion?
Yeah,
Okay, perfect. So let me share my screen of today's lecture. So my screen is sharing with you.
yeah.
Okay. So today is our lecture number 8, and in this lecture, basically we will discuss about mass, weight, the difference between mass and weight, and we will discuss an important phenomena which is gravitational force. So have you ever learned about what is mass and what is the difference between mass and weight?
I think so.
Have you ever been know about this? What is mass and weight?
I know what they are, but I haven't been taught what distinctly the differences between them.
Okay. Although they are looking the same words like mass and weight, but there is a huge difference between mass and weight. Okay, we will discuss briefly in this lecture today. So our learning
Yeah.
objectives are basically the first thing we will distinguish between mass and weight. Then we will understand the main important formula of weight, which is W equals to mg. And then we will move on towards our second topic, which is the gravitational field strength. And at last we will solve some numerical problems involving weight. So let's start. First of all, we have to discuss the main thing, which is the differentiation between mass and weight. Basically, what is mass? Mass is basically the amount of matter in an object. You already know that everything in the universe are made up of matter.
Uh,
Yes, atoms, or you can say the combination of atoms becomes matter. And do you know what is the definition of matter? What is matter?
uh, Little particles joined together.
Yes,
I don't know.
particles join together. Yes, you're right. Basically, in physics, we can simply define matter as anything that occupies space and have some weight is called matter. Okay? Anything
Mm-hmm.
that are occupying some space and if they have some weight, so that is a matter. Okay, if you have a particle, if particle is occupying some space and if that particle having some weight, so definitely that particle is a matter. Okay, everything is a matter. You is a matter, I am is a matter. Okay, everything is a matter because we are occupying space and we also have a weight. Okay, so can you tell me in the universe which thing has no mass?
Light,
Yes, light. Or also, can you tell me, can light occupying some space
kind of, but kind of not, I
in the
guess.
space? In the space, is light occupies some space?
Uh, no.
Yes, no. Okay, right. So if light haven't occupying some space, also light haven't some you can say weight. So light is not a matter.
Matter.
Yes, light is not a matter. So mass, you can simply define mass is that the amount of matter in an object. The more the
Mm.
particles in the object, the more the mass that object have. the less the number of particles in the object, the less the mass that object contains. All right.
Hmm.
And you also know that what is the unit of mass? You can tell me which is
Nothing.
mass.
Nothing. Oh,
Unit of
sorry,
mass.
kilogram.
Yes. Unit of mass is kilograms. And the what is the quantity? Mass is a scalar quantity or a vector quantity. So here mass is a scalar quantity because mass have not any direction. It is random. Okay. Anything that have a specified direction, that is a vector quantity. Because mass haven't any specified direction, that's why we can say mass is not a vector quantity. It is a,
Scalar.
yes, scalar quantity. You know what is the difference between scalar and vector? We already discussed in our previous lectures.
Hmm.
Okay. So, are understood about what is mass?
Yeah.
Yes. The amount of matter in an object. This is known as the mass. Now move on towards weight. What is weight? Weight is basically the force of gravity acting on an object. Basically, any object contains weight. This is due to the gravitational pull. If gravity pushes your object more, that object contains more mass. If gravity pushes that object slowly, then you can say the weight of that object is low. So, weight is simply defined as the force of gravity acting on an object. So, on me and you, can you tell me is gravity acting on us or no?
Uh, yeah.
Yes, gravity is acting on us. Okay. And if gravity is acting on us, so we have some weight.
Uh, wait.
So, sometimes we are measuring our weight on weight machine, right?
Yeah.
So, can you tell me, basically, we are measuring our mass or weight?
Uh, mass.
No,
Both.
we are
Because.
measuring our weight. How?
Hmm.
Because you can see when you stand on a weight machine, gravity pushes you in which direction? Downward direction.
Uh, yeah.
Yes. So if gravity pushes you downward direction, so that's why your body contains some weight. So that weight can be calculated by the weight machine. So basically we are measuring our weight, not the mass. Okay.
Hmm.
This is an important
Yeah.
thing. So the more the gravity pushes you, the more the object's weight. The less the gravity pushes you, the less the object's weight. Okay. So weight is basically depends upon the gravity, whereas mass does not depends upon gravity. So we can conclude that mass is a constant quantity, whereas weight is a not constant quantity. Weight is not a constant quantity because it
Hmm.
depends on gravity.
Uh, yeah.
Weight depends upon gravity. And you also know that different planets have different value of gravity. Can you tell me what is the
Yeah.
value of gravitation of our Earth, Earth's gravity?
9.81.
Yes, 9.81. Correct, you are right. So this is the gravity value of our Earth. But can you tell me what is the value of gravity on Mars?
I don't know.
Yes,
Honestly.
it's different. It's not remain same which is on Earth. It is around about 3.7. Okay. So, because
Hmm.
the gravitational field is different on each planet, that's why our weight is also different on each planet. That's why weight is not a constant quantity. Weight depends upon gravity, while your mass is a constant quantity. Okay. So let's
Hmm.
suppose if your weight is 50 kg. Okay. Is my
Hmm.
voice is my voice is clear?
Yeah.
Okay, if your weight is 50 kg on Earth, can you tell me what is your weight on Mars?
Uh, would it be like 150 kg?
No.
Somewhere around those lines where
Mm, uh,
uh,
if your mass, sorry, I'm asking about mass. If your mass is 50 kg
oh,
on Earth, what is your mass on Mars?
oh, 50 kg because
Yes, perfect.
the
Remains
Martian
remains same. Okay.
constant.
Yes. And if your
Hmm.
weight is 60 kg on Earth, what is your weight on Mars? Is it remain same or must be different?
Different.
Yes, different. Why different?
Because Mars has a different gravitational pull.
Yes, great. So that's all. We have an important formula for calculation of weight. How can we calculate weight? If we know the value of mass of an object, we can easily calculate the weight of a body. Okay, so the formula of weight is W
Hmm.
equals to mg. The product of mass and gravity is called the weight, whereas m is the mass of an object and g is the gravitational pull. So if we know the mass of an object, we can just multiply by gravitational pull. We can calculate their weight. So W equals to mg. All right.
Hmm.
Okay, where W is the weight, and you know what is the unit of weight is newtons. Whereas m is the mass, and mass is measured in kg. Whereas g is the gravitational field. You can say the gravitational pull. Let's consider we are concerning about the Earth. So for Earth, the value of small g is 9.8 meter per second square. And for our easy calculation, sometimes we take 10 meter per second square. Okay, this is
Hmm.
the same difference which we already discussed. Mass is the amount of matter, whereas weight, it is the basically gravitational pull of an object. Whereas mass remains constant everywhere, whereas your weight, it always changes. It varies with the gravity. And mass is measured in kilograms, whereas weight is measured in newtons. And mass is a scalar quantity, whereas weight is a vector quantity. Why weight is a vector
Vector.
quantity?
Uh, is it because it has no direction,
Why
or
weight is a
is it
vector
because
quantity?
it doesn't have any direction?
Because it does have direction. That's why it is a vector quantity. Okay. The definition of vector
Oh.
quantity is vector quantity is a quantity that have magnitude as well as direction both. Okay. A scalar quantity is a
Hmm.
quantity that have only magnitude but not the direction. Because mass has no direction, that's why it's a scalar quantity. Whereas weight has a direction. Which direction? The direction of gravity. You know, gravity pushes in which direction? Upward or downward? Downward. Okay, so we can say because gravity pushes in some
Uh,
specified direction,
mhm,
that's why we can say our weight is a vector quantity. Okay,
mhm.
any question regarding mass and weight?
No.
Okay, now if no, and then we can move on towards our next topic, which is gravitational field strength. This is the same which we already discussed. Gravitational field, you know, the value of gravitational field value and strength means power. The more the gravity the planet has, the more the strength they have. If some planet have less gravitational pull, then their gravitational field strength is also low. Okay, so how can you define the gravitational field strength? Is that gravitational field strength refers to the force of gravity per unit mass at a specified point in space. It means if your gravity pushes some object per unit mass, okay, so this is known as the gravitational field strength. Okay, basically gravitational field strength quantifies you how strongly your gravity attracts object. If your gravity attracts objects slowly, we can say the gravitational field strength of that planet is low. If your gravity pushes objects fast, we can say the gravitational field strength of that planet is
Uh,
high.
High.
Yes, high. Okay. And we know what is the gravitational field strength of Earth, which is
9.8.
9.9.8. And what's the
8.
unit? Newton per kg.
Uh,
Okay,
hmm,
Newton per kg. And what does this Newton per kg means? It means if let's suppose 1 kg of objects experience a
t-
gravitational pull of 9.8 newtons. Means let's suppose an object
mm,
containing 1 kg mass and which is placed on Earth, and Earth pushes that 1 kg object with the gravitational pull of 9.8 newtons. So this means Newton per kg. All right.
mhm.
And gravitational field strength is denoted by capital G or small g.
Small g.
Yes, small g. And its value is on Earth 9.8, and the unit you know that it's Newton per kg. And as I already told you before, it varies on different planets. Different planets have different gravitational pulls. That's why we can say different planets have different gravitational field strength. So, what's the value of
Mm.
gravitational field strengths on different planets? You can see from this table. So, you can see here on Mars, what is the value of gravitational field strength?
Uh, is it 3.7
Yes, 3.7.
newtons per kg?
Yes, newtons per kg. What is the gravitational field strength of Neptune?
11.2 newtons per kg.
Okay. So, can you tell me which planet has the most value of gravity?
Uh, is it Jupiter?
Yes, Jupiter. What's its value?
24.8
Yes,
newtons per kg.
yes, 24.8 kg. So, can you tell me if your weight is 50 newtons on Earth, and what's your weight on Jupiter? Is it increased or decreased?
Uh, Increased.
Increased. By how many times?
Uh, 20 times, 24.
Yes,
Oh,
24.8
25.
times. Yes, almost 25 times your weight increase if you go to the Jupiter. Okay. So which planet has the least value of gravitational field strength? Or you can say the gravity?
Pluto.
Yes, Pluto, which is zero point 0.6 newtons per kg.
Pluto.
Yes. Any question? Any question?
Nah, no question.
Okay. Now let's move on towards our worked examples. Is my voice is clear?
Yeah.
Okay.
Yeah.
So now move on towards our work. Some work examples. Our first example is what is the weight of a 4 kg object on Earth? So this problem demands you to find,
Uh, Wait.
yes, weight. Which things are given in this statement?
The mass
Yes,
and where it is,
yes,
like
the
what
mass.
planet it's on.
Yes, the important thing is also given, which is the planet name, which is Earth. So there is a hidden detail inside this word Earth. So if you know this is Earth, so you know what is the gravitational field strength of Earth, which is 9.8.
9.8.
And they're asking you to find the weight, and the formula is simple. You know that if the mass is given and you know which planet is this, you can easily find their weight, which is W is equals to mg. Just multiply your mass, which is 4 multiplied by the gravitational pull of Earth, 9.8. You will get your answer, which is 39.2. And what's the unit of weight is newtons.
Newtons.
Hmm. A body has a weight of 100 newtons. What is its mass? Now the weight is given. They are asking you to find the mass. Can you find mass?
Mass.
If weight is given?
Yeah.
Yes. The simple, again using the same formula, W is equals to mg. Because you have to find the mass, you can substitute your expression for mass. So G goes in denominator. So M becomes equal to W by G by just putting the value of weight, which is 100, divided by the gravitational pull. Let's suppose asking for Earth. We know what is the value of Earth's G, which is 9.8. Just dividing, you will get your answer, which is approximately equals to 10.2 kilograms.
Mhm.
Third problem. What is the weight of a 5 kg object on the moon where G equals to 1.9 newtons per kg? Now again, what is given?
The weight
Yeah,
and
what is
no,
the
the
weight?
mass.
Yes, the mass is
Mass.
given, and they're asking you to
And
find the weight. And one more thing is given, which is
the planet and the gravitational pull.
yes, the gravitational pull. Because mostly some students do not know what is the gravitational pull of moon. That's why sometimes in problem they would given you, which is 1.6 newtons per kg. This is the gravitational pull of moon. By just simply multiply your mass, which is 5 times your gravitational pull, which is 1.6, you will get your answer, which is 8 newtons. A watermelon has a mass of 2.5 kg.
Mm.
What is its weight on Earth? Now, the mass of watermelon is given, which is 2.5 kg. They're asking you to find their weight on Earth. Simply, you know that just multiply your mass,
Mhm.
which is 2.5, times your gravitational pull of Earth. You know it's 9.8. You will get your answer, which is 24.5 newtons. Understood?
Mhm.
Wonderful. An astronaut weighs 800 newtons on Earth. What is their mass? Now again they're asking you to find the mass. You know the formula of weight, which is W is equal to mg. You have to substitute your expression in terms of for mass. So mass becomes equal to W by G. They're asking you to find on Earth. So 800 divided by the gravitational pull on Earth, which is 9.8, you will get your answer, which is approximately 81.63 kilograms.
Mhm.
Is there any question?
Uh,
And
no.
okay,
Mm.
Okay, so here some quick quiz for you. Can you define what is weight?
Gravity acts on an object.
Yes, gravity acts
Well,
on an object.
the force of gravity.
Yes, good. Can you tell me what is the formula for calculating weight?
W equals mg.
Yes, W is the formula. Okay.
W equals mg.
Yes.
Mm.
A 7 kg object is on Earth. What its weight? Can you find weight if the mass on Earth is given, which is 7 kg?
Yeah. Which is 68.6 newtons.
Yes. A 2 kg, a 2 kg object has a weight of 16 newtons. Find G. So what they're asking you to find?
Gravity.
Yes, gravity.
Gravitational force.
Yes, gravitational pull. So how can you find gravitational pull if mass and weight both are given?
W over, well, weight over mass.
Yes, weight over
Uh,
mass.
which
Okay.
equals to 8 newtons per kg.
Yes, 8 newtons per kg because you know the unit of gravity is newtons per kg. All right.
Mm. Mm.
State one difference between mass and weight. Can you tell me one difference between mass and weight?
Uh, Mass is constant, whereas weight changes.
Yes, mass remains constant whereas weight varies. Very good. Okay. So, any question?
No.
Okay. So to wrap up, again, you know that mass is a constant quantity. It remains constant everywhere, whereas your weight
Hmm.
depends on gravity. And for the calculation of gravity, mass, and weight, you can use a specified formula, which is W equals to mg. By using this formula, you can easily calculate weight. Sometimes they're asking you to find the mass, and sometimes they're asking you to find the gravitational pull, or you can say the gravity. So, mass, gravity, and weight, all these three things can be found by using this formula. Okay.
Hmm.
So by using this formula, we can practice some problems. So here is some assessment questions for you. So at home, you can just review and solve these assessment questions. Okay. In first
All
question,
right.
basically they're asking you to find mass. Again, the weight is given, and they use a word Earth. So you know what is the gravitational pull of Earth. In second problem, a suitcase has a mass of 15 kg, so the mass is given, and they're asking you to find the weight. And they specified a word which is Earth, so you know what is the gravitational pull of Earth. You can use their value. And in third problem, they ask you to find the weight. They said if the gravitational field strength on Mars is 3.7 newtons per kg, so this is what? This is
Uh, Gravitational pull.
Yes, this is the value of gravitational pull, which is 3.7. And what is the weight of 10 kg object? Means they're asking you to find the weight, and again the mass is given. Okay. So these are simple
Uh-huh.
problems. You can do practice at your home and you can revise this lecture. Okay. This is simple. Any question you can ask.
All right. Okay.
Okay. So if
Thank
no
you.
question, we can just close our today's lecture. Our next lecture would be on next Sunday. Okay, inshallah.
Hmm.
Lecture 9.
Okay. Right.
So take care.
Thank you.
Allah Hafiz.
You too. Right. Allah Hafiz.
Allah Hafiz. Peace.